Today we're going to do an introduction to lesson 10.5 on the binomial theorem. And actually we're just going to be working on some skills that we'll use to work out the binomial theorem, and tomorrow I will introduce the binomial theorem to you. So the first thing we need to discuss is the concept of factorials. In case you don't remember from Algebra 2, we have a mathematical operation called factorial. You can see 1 factorial right here simply just means 1. 2 factorial means 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. You can see the pattern there is simply taking that digit and then multiplying by successive digits that decrease by 1. Now, to find this operation in your calculator, you should be able to go, press a number, of course, and if you go to Math, and then go over to the probability menu, option 4 you can see is the factorial, and this would give us the same result as 5 times 4 times 3 times 2 times 1. Same result. So that's where the factorial function is on your calculator. Now, using this factorial feature, it leads us into combinations. And when we have factorials that are being divided, such as this one that you see, 7 factorial divided by 5 factorial, it means you got 7 times 6 times 5 factorial. And if you're dividing by 5 factorial, now you can cancel the 5 factorials, and you're left now just with 7 times 6, which is 42. This works for all types of factorials. So if you had, let's just say, 10 factorial divided by 9 factorial, that's the same thing as 10 times 9 factorial, still being divided by 9 factorial, and now the 9 factorials cancel, and so this just equals 10. Now we'll use that concept to do some combination problems. Now the first thing I want to discuss is, in case you don't remember from Algebra 2, combinations. If we had like, let's just say 5 combination, choose 3. The way this book writes it is like this: 5, 3 in a vertical fashion inside parentheses, like you can see up above. Okay, so based upon what combinations equal, 5 combination choosing 3 is equal to 5 factorial over 3 factorial times 5 minus 3 factorial, which would be 2 factorial. Now this would simplify into 5 times 4 times 3 factorial, being divided by 3 factorial times 2 factorial. I could now cancel the 3 factorials. And the 2 factorial is just 2 times 1. And now I can cancel the 2 with the 4, making the 4 a 2. So we should just get 10 for a result. But there's a much simpler way of doing this, and that would be to just use your calculator. So to get that result of 5 combination choosing 3, we type in a 5, we press the Math button, we go to the probability menu, go down to NCR, and then put a 3. Should get the same result of 10. Okay, so that's some notation that you're going to see, and you can certainly use your calculator to calculate that versus the way I did it, writing it all out. So, some examples. You can see this is 5, choose 0. There is one way to do that. Choose 0 items from 5. 5, choose 1. There's 5 different ways to do that. There's 5 different ways to choose 1 item from a list of 5. This is saying how many ways is there to choose 2 items from a list of 5, and there are 10 different ways to do that. 5, choose 3. There are 10 ways to do that. And just to continue down the line here, this is saying how many different ways is there to choose 4 items from a list of 5, and there are 5 ways to do that. And how many ways are there to choose 5 items from 5 items? There's only one way to do that. That's choosing all 5. So the last type of problem I want to talk about today is it's going to give you an expression like this: 3n plus 3 factorial divided by 3n factorial. And it's going to say to rewrite this expression so that it does not contain factorials. Well, I'm going to rewrite the numerator as 3n plus 3, 3n plus 2, 3n plus 1 times 3n with a factorial behind it. Basically, I just decreased each of those by 1. And the bottom stays as 3n factorial. And now I can cancel the 3n factorials out. And so I'm left with 3n plus 3 times 3n plus 2 times 3n plus 1. So to give your final expression, you don't need to FOIL that out. You can just leave it in the factored form. So you're going to have a couple of problems like that for today's problems. So day 1 of lesson 10.5 is just going to be to do 1 through 18 all. This is going to be collected tomorrow. And then tomorrow we're going to discuss how we use these skills to work out the binomial theorem. And you'll have day 2 problems tomorrow. But I'd like you to start and complete 1 through 18 for tomorrow. Not that long of an assignment. Have a good day.